So I'm recording all of today because a lot of people are absent today, okay? What we just did is day 5 of our notes, and our warm-up consisted of a 15-minute warm-up for bonus points. Completely solve and completely factor the following things, okay? Now, please, as far as bonus points go, you're not writing anymore. But if you need to put these in your notes for clarification, please do so, okay? Because there's a lot going on here. So I'm going to solve these out fairly quickly, but you can see where you went wrong or where you did it correctly. And if you have some missing pieces, just add them in. So the first one, I see a difference of cubes immediately. Okay, the reason why I see a difference of cubes is I can take the cube root of an 8 and an x cubed, and I can take the cube root of 27. And what we learned not too long ago was that a difference of cubes will have 2 terms and 3 terms. This is a negative, so it's the same, opposite, always positive. The cubed root of the first one is 2x. The cubed root of the second one is 3. And then I square this term to get 4x squared, and I square this term to get 9. When I multiply these together, I just get 6x. Please, again, don't think of multiplying a negative 3 with the 2x and saying a negative 6x, because you'll get that wrong. SOAP takes care of the signs, okay? So, same, opposite, always positive. Okay, so from here, we know that 2x minus 3 is done because it's to the power of 1. And then I can ask myself, how can I factor this? And the way I would look at this is I would try to do 2x and 2x, which gives me this 4x squared. I would try to do 3 and 3, which gives me this 9. And look, 6 and 6 is going to give me a 12 or a 0. You see what's going on? So that's too much. We want a 6. Okay, so what should we try now instead of 3 and 3? We could try 9 and 1. You with me? So 9 and 1 will give me this 9, but I have 18 and 2. 18 and 2 will give me 20 or 16. It's still not working out. So the last thing that I would do before trying to do a quadratic formula is I would see, can I alter this 2 and 2 to like a 4 and 1? So that takes care of this. And then if I do 3 and 3 or 1 and 9, it may work. You see what I'm saying? So 3 and 3 will give me 3 and 12, which would be 15 or 9. It's still not the 6 that I need. So the last thing that I could possibly do would be a 9 and a 1. Okay? So 9, 1 could give me 9 and 4, which is 13 or 5. So the reason why I did that is there's a lot of algebra that I just did, a lot of mental math that I just did. But nonetheless, to me, I feel like those are the ones that you kind of want to gravitate to first and build that practice, especially because of what we're doing today. Okay? What we're doing today, there's a lot of that math kind of going on to where it's easier if you've had a lot of experience and practice with what I just did just now. Okay? Alright, so because that didn't work out, yes, we have this huge chart on the board that I've been telling you guys about all week, because there's many forms of factoring. Okay, from here, I'd probably use the discriminant test, b squared minus 4ac, and see that this would be 36 minus 4 times a times c. Is it positive or negative? Negative, so I'm going to have imaginary roots. Okay? So looking at this, this is negative 4 and 16, or 4 is 16, 9, we get, because we're doing this by hand, we get 144. 144 minus 36, because it's going to be 36 minus that, 14 is going to be 8, and I'll have 10. Say again? Alright, so any questions on that? Do we agree on this? Okay, so this is going to be a negative 108 is my, okay, so let's go ahead and start solving this out. negative b plus or minus the square root of b squared minus 4ac, which is that, all over 2a. Are we good? Okay. So from all this, I would probably change this 2 times 4 in the denominator just straight to 8. And then I'm going to think about how can I simplify this radical, this 108. Okay? Immediately I start seeing the primes like 2 times 54. Okay? And 54 is kind of a big number that I could probably say 9 and 6. And already I can see I'm going to pull out this 9 as a 3. You see it? And then the other one is that I could make this a 2 and a 3. So right now, underneath this radical, it's the same as if I were to write, let me show you, instead of 108, all the factors that you just saw, which is 2, 9, 2, 3 with a negative 1 attached. That's a negative 1, not a 7. Make sure you understand that. Okay? Questions? So this 9, you help me out. This 9 is going to come out as a 3. These 2's will come out as a 2. So on the outside I have 6. What will this come out as? I. So I have 6i, and that little root 3 stays in. Okay? Everything else came out. Plus or minus, we have this negative 6, and we have 8. Because this is the square root of negative 1. Okay? So now we can simplify. I think I already heard it. Because it's all over 8, the word common denominator says, that's it, 6i, is that we could do this, as individually over 8. Okay? So this first term is going to simplify to what? Negative 2/3. And this will be a 2/3 as well, right? So it's like plus or minus 2/3 I root 3. Oh, why did I say 2/3? Oh, I'm sorry. It's 3/4. Okay, no worries. Nice catch. And I will fix that. So this would become, dividing by 2 would be a negative 3/4 and a 3/4. So right here, this is x equals all of that is a 0. Not a factor, but a 0. Okay? What would be the 0 here? Say again? 3/2, right? Because you would set it equal to 0. So my goal was this, and we could say that factored fully is kind of coming from this, and then taking this and doing the quadratic formula to get those two imaginary solutions, and then this is the real solution. Raise your hand if you got that. Okay, so that one was a little hefty for sure. There at the end to factor completely. Okay, but nonetheless, this was the first level of factors that I believe most of you. Raise your hand if you got there. Okay, so with practice, we will get better. But now let's move on to the next one, because I want everyone to see like all the solutions that you get. Because this factor here, if you set it equal to 0, you add 3 and divide by 2. And then you get 3/2. Okay? Oh, just watch the video later if you can, please. Only because I don't want to. Or just take a picture of the paused video, please, because I got to go. All right, so 2, or number 2, let's go to, actually, let's just do, yeah, we'll do them in order. 2. Is 2 a sum of cubes? No, because I can't take the cubed root of 2 and get a nice clean integer. I also can't take the cubed root of 54, or can I? Can I take the cube root of 54? Let's try 4 times 4, 16. Let's try times 4 more. So we have 4, 2, 64 I can. But, oh, my bad. But I can't do a 54, okay? So 64 I can, but 54 I cannot. Okay? So it's not going to be a sum of cubes. What do you suggest that we should have done to start factoring 2? GCF. Yeah, GCF is first. So 2x cubed plus 27, that's the first factor that I've gotten out. Okay? And now you see a what? Sum of cubes. So the x cubed plus 27 is going to become same, opposite, always positive. The cube root of the first term is x. The cubed root of the second term is 3. This will make this become an x squared. This will make this become 9. And these two will make this become x squared minus 3x plus 9. Okay? Now I just got to ask myself, so far that's a factor. X plus 3 is a factor. And can I fully reduce this all the way down? So you probably already see the x's make x squared. Good to go. But then we go back to this 9. And it'll be 3 and 3 or 1 and 9. If it's 3 and 3, this will produce a 6 or a 0. That's not what I need. If it's a 9 and 1, this would produce a 10 or an 8. That still isn't what I need. So from here, we could move on straight to what? Quadratic formula. Okay? And primarily the discriminant test. So at least it tells us what kind of answers are we looking for. Okay? So b squared minus 4ac, this will give me a positive 9 minus 36, which is a negative what? Negative 27. So it is going to be imaginary that we're going to have in our radicand. The number underneath the radical symbol is going to be a negative 27. So we'll have negative b plus or minus the square root of all of that b squared minus 4ac all over 2a. Simplifying this out, I'll write it up here so that you can see it in the back. Gives me that. Yep, so 27 is like 9 times 3. Negative 9 times 3. So the negative 1 comes out as an I. The 9 comes out as a 3. And that other 3 stayed in. Okay, so the 9 and the negative 1, they came out as 3i. You with me? Yeah. So we get x is equal to negative 3 and 3 plus or minus 3 root or 3i root 3 all over 2. And yes, some of you might elect to do 3 plus 3i root 3 over 2, comma 3 minus 3i root 3 over 2. And that's okay. Yes?
I'm still a little confused how you went from the, like, how you got to that blue equation, like the one with the trinomial.
Oh, so you're going to have to see the notes was from last class.
Okay.
She was absent last class. I'll let her refer to the video notes over the weekend. Okay?
Is that the one with you in New York?
But I re-recorded it for 7th period, and it's better because you have those questions back and forth. All right. Questions? All right, so let's do, just so I don't have to scroll all the way down, let's do 4 real quick. 4 immediately, depending on the level of your experience and practice, like if you're postponing and you're procrastinating homework, this is probably really hard right now, okay? You have to do this practice earlier on to see all of this. Well, what could I do next? If I see 4 terms, I immediately try to go straight to, if I can't GCF anything out, I go straight to the factor by grouping method. So pairing up and trying to GCF. So y squared is the biggest thing that I can pull out. And what are the scraps? Y minus 2. From this other one, 2 is the biggest thing that I can pull out. And what are the scraps? Oh, my bad, not 2. 4 is the biggest thing that I can pull out. And I'd get y minus 2. Notice the pair is one of your factors. If those pairs are not equal, and they're not the same thing, either you did something wrong or you can't factor it using that method. Okay? And you might have to try something different, which is what we're going to learn today. Yeah. So this would be y squared plus 4. This would be fully factored. Okay? And the reason why is, even though this is a squared and you're thinking, ooh, I could factor that more, there's no such thing, and we experienced this during notes in class, there's no such thing as a sum of squares. So it's going to factor differently. And the way we did it in class is y squared plus 4 is equal to 0. I'd move the 4 over, and when I square root, I got to remember that plus and minus, so that I'd get plus and minus the square root of a negative 4, which is what? 2i. So you have a positive 2i and a negative 2i. Watch what I do real quick. If I want to account for the positive 2i, it would be like writing the factor x minus 2i. If I wanted to account for this negative 2i, it would be like writing the factor x plus 2i. So if I brought this down, I could say that this is the fully factored form. Notice that I have these imaginary roots and factors always occurring in pairs. Okay? So my answers would be x equals 2i. This one is negative 2i. And yes, you could do plus or minus all as one. And then 2. Not x, but y equals that. Yes?
When you were like pulling out the greatest common factor and you just wrote plus 4.
Yeah, because the second pair.
Positive.
Well, the thing is that my goal is whatever I decide to pull out from this second factor or the second pair, my goal is to try to make this match. So I might have to pull out a negative, I might have to pull out a positive. My goal is to make it match. And if it does, then what's inside is one of my factors, and what is outside is the other factor. That's factored by grouping. Questions on this? Okay, so let's move on to number 5. What do you think I would do first? Subtract the 21 and set it equal to 0. So, and I would also put it in descending order like that. From here, I would probably try to see if I could GCF. Can I GCF?
Yes.
A 3, right? So if I put out a 3, the scraps would be x to the 4th minus 7x squared plus 6. Say again?
A equals x squared to get a squared minus 7.
Oh, okay. So some people would say a equals x squared. Remember, we experienced this in our notes. So that you could write a squared minus 7a. There's that x squared. Plus 6. Then solve for a. Resubstitute back in your x squared and solve for x. If you did that, this would be a minus 6, a minus 1. So that your solutions would be a is 6 and 1. That means x squared is 6, x squared is 1. Some people may not like that a substitution method. To be honest, I'm one of those people, unless it deals with sine and cosine that you will learn in pre-calc. I would probably, from here, just see, ooh, an x squared and an x squared can give me an x to the fourth. And then I would see this 6, and I'd say a 6 and a 1 that are both negative. Here we go. I'll highlight it as I go. This x squared, come on computer, will give me this x to the fourth. This negative 6 and negative 1 gives me a positive 6. And the negative 6 and a negative 1 gives me a negative 7x squared. So that here, when I solve it, setting it equal to 0, I would still get that piece. And over here, I'd get x squared is equal to 1. You with me? Okay. Real quick. You see x squared minus 6, and you see x squared minus 1. It isn't fully factored yet. I could, if I wanted to, factor it even more, because it's a difference of squares. This 6, you're probably thinking, I can't take the square root of 6 and get a nice clean number. It's okay if you can't, because you would write x and x, I'm coming from here, and you would write root 6 and root 6. There's still a difference of squares. They're just not integers. And the same thing here, a difference of squares. One's a plus, one's a minus. They're both x's, and 1 is the square root of that. This would be fully factored. Well, you don't need the square root on this one, because what is the square root of 1? 1. So you can keep it as 1. You see that? So the answers would be x is equal to a negative root 6, a positive root 6 in order, a negative 1, and a positive 1 at the end. Okay? Questions? There's a lot going on with these for sure, guys, as far as practice. The hardest ones, in my opinion, you will see today. Okay? And they're the hardest because you have to put everything together, and at the same time, they're dealing with fractions, which a lot of people don't like fractions. Okay, here we go. So I see a trinomial. Some people might change those x to the fourths to a squared and so on and so forth, right? The way we did on that last example. And then solve for a. I'm not that one of those type of people. I would keep it as what two things multiply to get x to the fourth? X squared. And I know that 4 is either 2 and 2 and 1 and 4, 1 and 4. I'm going to use the 1 and 4 because I want to get this 5 to happen. And they just both have to be negative to make all the foiling happen out. Okay? Is this fully factored? No. Because difference of squares says I can break the first one to an x plus 1, x minus 1. And I can break the second pair to an x plus 2, x minus 2. So that the full answers for zeros, x-intercepts, will be in order: negative 1, positive 1, negative 2, positive 2. Yeah? Yeah, if it was a plus 4 here, then you could factor this one to this, but then you would just move that up and say it's fully factored per se, real numbers wise. Or you would do this as far as the imaginary that you just said, set it equal to 0, and solve for the x. So here's what I'll say. If you do it like this, a lot of people forget the plus and minus right here. But it's 2i. Believe it or not, some people choose to learn and force themselves that there is a sum of squares. I'm one of them. Because if I see x squared plus 4, I know that it's going to be imaginary. And when I factor this out, like these right here, do you see that you have a positive 2i? And you have a negative 2i? These could be written like these factors right here. I just don't show people this per se when I'm teaching you, because some people get it, but a lot of people don't. I see this as a sum of squares where it's still going to be x, but instead of plus minus a number, it'll be plus minus imaginary numbers. You see what I'm saying? So a sum of squares I would still treat like a difference of squares. But when I see that 4 right there, I'm not thinking 2 and 2. I'm thinking 2i and 2i. So if you want to use that, you are more than welcome to. Just don't call it a sum of squares. Do you understand? Because it's not those aren't real numbers. Okay? That's why I teach this, where you set it equal to 0 and then solve it out. Most people remember that. And it reinforces the thing that I experience with a lot of students, even with ACT and SAT test prep, that they forget this plus or minus thing right here when you are square rooting, or when you take the 4th root or the 6th root, any even number that you're taking that root. Okay? And the ACT and SAT know what people struggle with. You know what I mean? And they continue to test those ideas and topics to make sure that people are, you know what I'm saying? Just not to inflate scores. But those of you who are, or teachers who are well versed with that test, they can warn you guys big time with those red flags. Last one. You could move the x to the 5th to the right. If you did, it would look like this. I'm not one of those people. I like to keep my leading coefficients positive, so I would move everything to the left. Either way, you're going to get the same answer. But in my experience with students, when you have that negative a value, they tend to make more negative mistakes compared to if it's a positive with everything in math. Okay? So from here, I GCF out an x. You tell me, please, what are the scraps?
X to the 4th minus x squared minus 12.
And you see it already. This will be an x squared factoring. Right? What are the other numbers going to be? Not 6 and 2, 4 and 3. Because it'll make this negative 1 happen. Can I factor more? I can. A difference of squares I can factor more. To what? X plus 2, x minus 2. And I know it doesn't exist, but I just showed you, you could treat that as a sum of squares if you want, by doing it the same way, but instead of square root of 3, what are we going to have? We're going to have an imaginary. So we're going to have this I root 3. I root 3. See, and people's faces are a little bit like confused because that just doesn't sit well. That's why I would say, all right, if that doesn't sit well, no worries. Set that equal to 0. Subtract the 3. Whoops, this should be a 2 right here because it's squared. And then get the plus or minus answer. What comes out? The I. What stays in? The 3. This is that negative answer, and this is that positive answer. Because these are the roots, those are the corresponding factors. And you would finally say this. X equals 0, negative 2, 2. And then plus or minus I root 3. We just did a lot. This was all cumulative. It was all review. I'll get the bonus points at the end. Just keep track of them. But I want to immediately segue into the new stuff. Okay? Because the new stuff is dealing with other methods with the harder problems. Okay, so those are the answers in case you want to take a quick picture. Notice, guys, look, when we had these weird imaginary answers, you watching? These weird imaginary answers, the most simplified form was here. The most simplified form was here. Okay? You didn't see factors just keep going on as far as the way they were written. It just went straight to the zeros. All right, the new stuff. Let me start with the different videos so that people knew that that was the warm-up. And here comes the second video. Can you help me out, Thomas, please?